Okay, we are going to discuss theory paper 1, question number 4. Theory paper number 1, question number 4. It tells us a vehicle travels along a straight road. The vehicle starts to move at rest. So it means initial velocity is 0 meter per second. It travels with a certain constant acceleration. So I mark the acceleration as a1 meter per square seconds. So at the end of the acceleration period, it obtains a certain velocity. I'll mark it as v. Then it travels with this obtained velocity. So velocity of the object when it reaches to B is v meter per second. Then it travels from B to C with this obtained velocity. So it means velocity of the object remains unchanged as v meter per second when it travels from B to C. After that, it decelerates. And finally, the vehicle comes to rest. At point D, its velocity becomes 0. So C to D, I'll mark the acceleration of the vehicle as a3 meter per square seconds. BC section, I'll mark the acceleration as a2. But as the vehicle travels with the constant velocity, acceleration from B to C is 0. I can mark them later. Right? What's the point? When an object is moving with the constant velocity, acceleration is 0. I'll explain it further later, but not now. A to B time taken, let's say t1 seconds. Displacement from A to B is given as 3 kilometer. 3 kilometer means 3000 meters. B to C time taken, I'll mark it as t2 seconds. S2 displacement. Somebody is unmute the mic and tell me. And T3 is the time taken for the vehicle travel from C to D. S3 is the displacement from C to D. Please draw this figure for the theory paper 1, question number 4. Right? Start. B to C displacement is given as 7 kilometer, means 7,000 meters. 7 kilometer means 7,000 meters. C to D displacement is given as 2.5 kilometer. So 2.5 kilometer means 2,500 meters. So I have marked all the given data. I should find everything, right? I have to find everything. So these are the equations that we are going to use. These equations are said to be linear motion equations. I'm going to use these equations to solve this problem. So it means I'm not going to draw a graph. So this is mechanics lesson, linear motion section. Start. I have sent the question paper to WhatsApp group here. Please check your WhatsApp group. You will find the questions. Once you have drawn the figure, please send me a message saying done, because I can't see your books. The point here is they have given nothing. What's the point? They have given nothing. So T1, T2, T3 not given, A1, A3 not given, velocity at B not given, velocity C not given. So the almost everything is not given in this question, right? Look at board. Look at board. A to B, velocity increases, acceleration. So when the vehicle travels from A to B, velocity increases as 0 meter per second, 1 meter per second, 2 meter per second, 3 meter per second, 5 meter per second, like that. So A to B velocity increases. For example, let's say velocity at the point B is 5 meter per second. Just imagine initial velocity 0. Then velocity increases 0, 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, and 5 meter per second. So velocity of the vehicle when it reaches B is 5 meter per second. Then it travels from B to C with that 5 meter per second velocity. So until it reaches to point C, velocity of the object remains unchanged as 5 meter per second. C to D travels with a deceleration. Therefore, velocity decreases as 5, 4, 3, 2, 1, and 0. Finally, once it reaches to D, velocity is 0. Got it? So, according to my description, A to B velocity increases up to 5, B to C velocity is 5 meter per second, C to D velocity is reducing 5, 4, 3, 2, 1, 0. So, according to that description, the maximum velocity obtained by the vehicle is 5 meter per second, and that velocity is obtained at the point B. According to my descriptions, explanations, the maximum velocity of the object is 5 meter per second, and that velocity is obtained by the vehicle when it reaches to B. So therefore, we can say velocity of the vehicle is maximum at the point B. So and it travels from B to C with that same maximum velocity. Got it? Please mark velocity at point B, Vmax, and B to C, the same Vmax velocity is kept by the vehicle. If you have any doubt related to this Vmax case, please ask. I can again explain. I can again help you. Start. Right. So when many things are not given, even acceleration not given, the best equation is the second equation. So when a lot of things are not given, we use this is called average velocity equation, right? So when we are going to apply an equation, we should do two things. the first thing we should indicate the section that we are going to apply equation. There are three sections: AB section, BC section, and CD section. Got it? So I'm going to apply this equation A to B section, and I'll indicate the direction. Object is moving to the right hand side, so I'll indicate the direction as right hand side. So what are two things that you want to do when you apply a linear motion equation? You want to indicate the section, AB section, and the direction, because B, U, A vectors have direction. So all the vectors are in the moving direction, same direction, right hand side. So after that, I'll write the equation S over T equals U plus V over 2. S over T equals U plus V over 2. A to B displacement 3000 meter. 3000 meter. We should not use in kilometers. A to B time taken T1. U is the velocity at the point A. U is the initial velocity. It is the velocity at the point A. That is 0. V, final velocity. When we consider AB section, velocity at B is the final velocity, that is Vmax. Everything divided by 2. Got it? Then what are the things that we have written? Initial velocity is the velocity at A, that is 0 meter per second. Final velocity is the velocity at B, that is Vmax, divided by 2. So I have applied this equation from A to B section. So finally we have 3000 over T1 equals 0 plus Vmax is Vmax divided by 2. After that, I take 2 to this side, Vmax to this side, and I take T1 to the other side by using cross multiplication. 2 comes to this, 3000 into 2. Vmax comes down, and T1 goes to the other side like this. 2 into 3000 is 6000. Finally, we get 6000 divided by Vmax equals T1. This is our first equation. Complete. And if you have any further doubt, please ask. Do not hesitate to ask any question. I'm here to help you. Start. Then let's apply the same equation to the BC section. So we should indicate the section correctly, B to C. To this direction, we apply the equation. The average velocity equation is going to be applied for B to C section. B to C section. To this direction, I apply the equation S over T equals U plus V over 2. If you consider BC section, the displacement is 7000 meters. We do not use kilometers. So B to C section, the displacement is 7000 meters divided by The time taken for the object to travel from B to C is T2 seconds. That is T2. Equals U. U is the velocity at the point B. B max. B to C section. Initial velocity means velocity at the point B. That is V max. Final velocity is the velocity at the point C. That is V max. It means initial and final velocities are equal. So U is V max. V is also V max divided by 2. Is it clear here? Is it clear? Velocity at point B is the initial velocity, that is V max. Velocity at C is the final velocity, that is also V max. So initial and final velocity both V max, V max. V max plus V max, 2V max. So then we will get 7,000 divided by T2 equals 2V max over 2. This 2 and this 2 cancelled out. Finally, we will get that. Finally, we will get that 7,000 over T2 equals V max, 2 and 2 cancelled out. We have only V max. So after that, I'll apply cross multiplication like this. Then you will get 7,000 over V max equals T2. So let's say this is the second equation. So we have obtained expressions for T1 and T2 both. Start. Right, I think you have written both T1 and expressions for both T1 and T2. I'm going to apply the same equation and I'm going to obtain an expression for T3, right? To obtain an expression for T3, I'm going to apply the equation for C to D section, right? So from C to D section, to this direction, I apply the equation S over T equals U plus V over 2. In CD section, displacement 2,500 meter, the time taken T3. So displacement is 2,500, time taken is T3. U is the velocity at the point C. V means velocity at point D, initial velocity at C. Final velocity at D. So initial velocity is V max. The final velocity is 0. Time taken is 2. So this is 2,500 divided by 2 equals V max plus 0 is V max divided by 2. Right? Sorry, this is T3. This is T3. So then I use cross multiplication to take 2 to this side, T3 to the other side, V max to this side. So 2,500 into 2 divided by V max equals T3. 2,500 times 2 is 5,000 divided by V max equals T3. So let me take this equation as my third equation. So I have 3 equations for T1, T2 and T3. Complete them all quick. Write them all. After that, we can use the third equation, the given data. They have given that total time taken for the motion as 15 minutes. So I'm going to use that data to obtain the final answer. Look at board. It is given in the question that the total time taken. The total time taken is given as 15 minutes. 15 minutes should be converted into seconds. Therefore, this should be multiplied by 1 minute means 60 seconds. So this should be multiplied by 60. Then minutes converted into seconds. But total time taken means, T1 plus T2 plus T3 equals, it is 15 into 60. T1 is given by this expression. What is T1? 6000 over Vmax. So in the place of T1, I can write 6000 over Vmax. In the place of T2, you see, according to the second equation, T2 is 7000 over Vmax. So in the place of T2, I write 7000 over Vmax. In the place of T3, what is T3 here? According to the third equation, T3 is 5000 over Vmax. 5000 over Vmax equals 15 into 60. You can write 0 here. 5 times 6, 30. 3 remaining. 6 times 1, 6 plus that 3, 9. So 900. Can you do the rest and find the value of Vmax? Give a try. Try to find the value of Vmax quick. So I think it's very easy to simplify, right? We have obtained 3 expressions for T1, T2 and T3. T1 is given by 6000 over Vmax. First equation. T2 is given by 7000 over Vmax. Second equation. T3 is given by 5000 over Vmax. Third equation. Right, so I'll erase this side because I have written all the equations there. Now look at board. If you consider these three terms, Vmax, 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 the three denominators are same. Therefore, we can take Vmax as the common denominator for all the terms. For all of these terms, I can take Vmax as the common denominator. So Vmax is the common denominator. The remaining terms here, 6000 plus 7000 plus 5000 equals 900. So common denominator is Vmax. 6000 plus 5000, 13,000 plus 5000 means 18,000. If you add these three numbers, you will get 18,000 equals 900. So after that, we can use cross multiplication to interchange the terms. Then we will get 18,000 divided by 900 equals Vmax. Therefore, Vmax is equal to, these two zeros can be cancelled out, 18,000. These two zeros can be cancelled out. 180 divided by 9, 18 divided by 9 is 2, 0 divided by 9 is 0. So it means the maximum velocity obtained by the vehicle is 20 meter per second. Complete? Write them all. After that, let's find T1, T2, and T3. That's what we should do next, right? So let's try to find T1, T2, and T3. So that's what we should do next. I can use the first equation to find T1. The first equation tells us T1 equals 6,000 divided by Vmax. So 6,000 divided by Vmax is 20. 0, 0 cancelled out. 600 divided by 2 is 300. Therefore, time taken for the object to travel from A to B, 300 seconds. Then I'll use the second equation to find T2. I'll use the second equation to find T2. The second equation tells us T2 equals 7,000 divided by Vmax. 7,000 divided by Vmax. So it is 7,000 divided by Vmax is 20. So this 0 and this 0 can be cancelled out. 700 divided by 2 is 350. So we have found T2 also. Now we want to find T3. To find T3, let's use the third equation. The third equation tells us T3 equals 5,000 divided by Vmax. 5,000 divided by Vmax. 5,000 divided by Vmax is 20. 20. So this 0 and this 0 can be cancelled out. 500 divided by 2 is 250. So we have found T1, T2, and T3. Complete. So what they have asked further, what's the next part of the question? Find the acceleration, find the maximum velocity, and find the decelerations. Okay. Look at both. We have found the maximum velocity. Already we have found the maximum velocity. So we want to find the acceleration. So we want to find A to B acceleration. Object accelerates from A to B. So very simple. Look at board. Look at board. Right? We have obtained T1, T2, T3. Now we are going to find the acceleration. Right. Look at board. A to B, I'll indicate the section. I'm going to apply this section, AB section. To this direction, I apply the equation V equals U plus A. If we consider AB section, velocity at A is the initial velocity, that is 0. Plus acceleration is A1 time taken T1. In AB section, final velocity means velocity at the point B, that is V max. This is V max. V max. So we have found V max as 20 equals 0, not needed, A into T1. So 20 equals A1 into T1. T1 is found as 300 seconds. T1 is found as 300 seconds. Take 300 to this side. 20 divided by 300 equals A1. 0, 0 cancelled out. A1 equals 2 divided by 2 is 1. 30 divided by 2 is 15. So A1 is 15 meter per square seconds. In the exam, yes, you have to divide. But for my papers, just keep the answer as a fraction because I wish to teach you how to work with fractions. So that's more important than dividing. Write it quick. Right, I think you have written this. Shall we go to the next part of the question means, shall we try to find deceleration? Anybody wants any more time to write this? Like go to the next question. You are completely silence. Right, I'll use CD section. I'm going to find the deceleration A3. Okay, so C to D section. To this direction, I apply the equation V equals U plus A. In CD section, the initial velocity is the velocity at C. So velocity at C is 0. V max, sorry. If you consider C to D section, the initial velocity means the velocity at the point C, that is V max. Plus acceleration from C to D is A3. So A3 is an acceleration. So please remember that in all the linear motion equations, simple A represents acceleration, not deceleration. So A means acceleration. Therefore, A3 is also acceleration. Time is T3. In CD section, the final velocity means velocity at the point D, that is 0. In CD section, the final velocity means velocity at point capital D, that is 0. So final velocity is 0. Even you see the letter V, don't be confused with it, right? So 0 equal maximum V max is 20. we don't know what the A3 is. We have found T3. We have found T3 as 250. We have found T3 as 250. Then positive 20 comes to this side, plus 20 comes to this side as minus 20 equals 250 times A3. 250 times A3. Then I'll take 250 to this side, minus 20 divided by 250 equals A3. 0, 0 cancelled out. Then we'll find that acceleration A3 equals minus 2 over 25. The unit is meter per square seconds. Acceleration A3 equals minus. Acceleration equals minus mean A3 is not an acceleration, it's a deceleration. So even it is given in the question that C to D travels with the deceleration. That's why we got a minus sign for C to D acceleration. Got it? The minus sign indicates that it's a deceleration, not an acceleration. Complete? Right, let's write the final answers. Simple A question asks us to find the acceleration. Right? So question number 4, they have asked 3 questions. Let's write the answers for the 3 questions separately. Right? Let's answer the 3 questions separately. Look at board. First, they ask us to find acceleration. So acceleration is A1. We have found it as 1 over 15 meter per square seconds. Then it is asked us to find the maximum velocity. Simple B question asks us to find the maximum velocity. Maximum velocity. Maximum velocity we have found Vmax as 20 meter per second. Vmax is found as 20 meter per second. C question is very important. It is asked us to find deceleration. If you say acceleration, from Z to D. So that is A3, if you use the term acceleration, you have to use the minus sign with this 2/25. Can you understand? If you use the term acceleration, it is minus because it's not an acceleration, it's a deceleration. But if you use the term deceleration, then no need to write the minus sign. For example, if you say deceleration, from C to D, deceleration from C to D, then you should not write A3 because A3 is an acceleration. So do not write A3 here. You write this 2/25 without the minus sign. So that's the difference. If you say C to D acceleration, that is A3 equals minus because there is no acceleration from C to D. But if you directly use the term deceleration from C to D, then do not use A3. A3 is an acceleration. Here we are writing deceleration. Then deceleration from C to D equals, write this 2/25 without the minus sign. So it's a positive value. Got it? That's the difference between acceleration and deceleration. Please write the 3 answers quick. Please write the 3 answers, and if you have any further doubt, please ask. Right. Before we go to the question number 5 of the paper, I would like to discuss a simple additional question. So please write this example. After that, let's discuss the question paper number 5. But you can use the same paper, same answer sheets to write it. So write it here itself. So please write example. This example will help you to understand the question number 5 given in the paper. So please write example. A vehicle starts to travel at rest. Along a straight road. With a constant acceleration of 0.4 meter per square seconds. A vehicle starts to travel at rest along a straight road with a constant acceleration of 0.4 meter per square seconds. 0.4 meter per square seconds. 0.4 meter per square seconds. Full stop. It accelerates for a period of. It accelerates for a period of. It accelerates for a period of. It accelerates for a period of 30 seconds. It accelerates for a period of 30 seconds. It accelerates for a period of 30 seconds. Full stop. Full stop. At the end of the acceleration period, at the end of the acceleration period, at the end of the acceleration period, comma, it starts to decelerate with a constant rate. It starts to decelerate with a constant rate. It starts to decelerate with a constant rate. Clear? It starts to decelerate with a constant rate, comma, for 10 seconds. It starts to decelerate with a constant rate, comma, for 10 seconds. For 10 seconds. Full stop. Full stop. If you want to repeat, please tell me. At the end of that 10 seconds time period, full stop and continue. At the end of that 10 seconds time period, at the end of that 10 seconds time period, at the end of that 10 seconds time period, comma, the vehicle comes to rest. At the end of that 10 seconds time period, the vehicle comes to rest. The vehicle comes to rest. Right, I'm going to ask 3 questions. I'm going to ask 3 questions under this description. But before that, if you have any further doubt related to this, it means if you want to repeat any sentence, if you missed anything, please ask, I'll repeat. Do you want to repeat any of the part of the question? Right, then Roman number 1. Find the maximum velocity. Find the maximum velocity. Roman number 2. What is the deceleration? What is the deceleration? Final question. Final question. Calculate the total displacement. Calculate the total displacement. So these are the 3 questions that they have asked. So these are the 3 questions that they have asked. I'm going to draw a figure to illustrate the question. Look at board. Look at board. It says that there is a vehicle. It starts to move at rest. So it means initial velocity is 0. It accelerates. The acceleration A1 is given as 0.4 meter per square seconds. It accelerates for a certain period, then it reaches to a certain velocity v. After that, it decelerates and finally it comes to rest. The final velocity is 0. Initial velocity is 0, final velocity is 0. The deceleration is not given, so we have to find what the deceleration is. But here, please remember that A1 acceleration, A2 is also acceleration. Both A1 and A2 represent acceleration. So as the object has a deceleration from B to C, so you'll get a minus value for A2. A2 is acceleration, A1 is also acceleration, but B to C travels with the deceleration. So once we do calculations, we will get a minus answer for A2. The time taken for this part is given as 30 seconds. The displacement we don't know. The time taken for BC section is given as 10 seconds, and we don't know what the displacement is, right? Please draw this figure quick. Please quickly draw this figure. Right, we have to say a usual thing about B to C section. You see, A to B accelerates, velocity increases. Please stop writing, just look at board. A to B accelerates, so velocity increases as 0, 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, 5 meter per second will be the velocity when it reaches to B. After that, velocity decreases. 5, 4, 3, 2, 1, 0. A to B velocity increases as 1, 2, 3, 4, 5, 6. B to C velocity decreases as 6, 5, 4, 3, 2, 1. So it means at the point B, the vehicle has its maximum velocity. So please mark, velocity of the vehicle is maximum at the point B. So mark it first. That's the first thing that you should recognize, right? So velocity is maximum at the point B because A to B velocity increases, B to C velocity decreases. Therefore, the velocity will be maximum at the point B. So please mark it. The next thing is, look at board carefully. Look at board carefully. I'm going to consider AB section. So A to B section is considered, and to this moving direction, I apply the equation V equals U plus AT. If you consider AB section, the final velocity is the velocity at the point B, that is V max. If you consider the AB section, the initial velocity U is the velocity at the point A, that is 0. Acceleration, A to B acceleration is A1, A to B time taken is T1. So then you will get V max equals 0 plus A1 is given as 0.4, T1 is given as 30. So V max equals 0.4 can be written as 4 over 10. Can you understand that, Max? If you divide 4 by 10, answer is 0.4. So 0.4 can be written as 4 over 10 into 30. Now you can cancel out this 0 and this 0. Then you will get V max equals the maximum velocity obtained by the vehicle is 4 times 3, that is 12. So V max equals 12 meter per second. Complete it here. Write it. So before that we are going to discuss question number 5, I want to discuss this example. This example will help you to understand question number 5, which is given in the paper. Then let's find this S1. Let's try to find S1. S1 is a displacement from A to B. To find the S1 displacement, I think you are able to here see if I write it here. A to B section. Please indicate the section clearly. To which that you apply the equation and indicate the direction. Apply the equation S equal UT plus half AT square. Could you please apply this equation for A to B section and try to obtain the answer without my help? You were trying it. So this is actually a 2023 AL class. Yes, this is an online class, and this is our third class, right? The third group. Because I was not able to gather all the students in the same day, so this is the third group. It means right. There are 3 classes, and the other thing is don't join to all the 3 classes, right? Then I can't manage. You should join to only group 1 or group 2 or group 3, right? Not to all the groups. Right. So if you consider this A-B section, the displacement A to B is 1. Initial velocity means the velocity at the point A, that is 0, time taken 30 seconds, plus half, acceleration given as 0.4, the time taken 30, we have to get the square. So S1 equals 0 into 0 multiplied by 30, 0 into anything 0, plus half. 0.4 can be written as 4 by 10. 30 square is 900. 30 square is 900. Right? So then S1 equals, we don't worry about this 0. We can cancel out this 0 and this 0. 4 divided by 2 is 2. So here then we have 2 into 90. So S1 equals 2 times 9, 18, 180 meters. Who has obtained this answer? Who got this answer? This 180 is the displacement from A to B. Who got this answer? You can raise your hand. Dulmi. Dulmi got the answer. What about the other students? Himaya. Himaya got the answer. Any other students? Out of 100 students, only few got the answer. Anupami got the answer. Anupami Abesingha. Any other students who got this answer? Okay, now okay. Right. If you are lazy to raise the hand up. Good. Right. So we know Vmax, we know S1. Now we want to find A2 and we want to find S2. The best equation that can be used to find A2 is V equals U plus AB. So look at board. Look at board. The best equation that can be used to find A2 is V equals U plus AB. So A to B section, no, not A to B, not A to B. A to B case is over. B to C section, to this direction we apply the equation V equals U plus 8. If you consider BC section, final velocity is the velocity at the point C, that is 0. In BC section, initial velocity means velocity at the point B, that is V max. So acceleration, B to C acceleration is A2, time taken is T2. 0 equals V max is 12, A2 we don't know, T2 is 10. Plus 12 comes this side as minus 12 equals A2 times 10. So if you take 10 to this side, you will get minus 12 divided by 10 equals A2. So 12 divided by 10 is 1.2. So it means A2 equals minus 1.2 meter per square seconds. So A2 acceleration equals a minus value. The minus value of the A2 acceleration indicates that it's not an acceleration, but it's a deceleration. Complete the note, dear. Quick. Please quickly complete the note. Right, so the next thing that we want to obtain is S2. To obtain S2, I'll apply the same equation of S equal unit plus half L square now to B to C section. If you consider BC section, B to C displacement is S2. B to C displacement is S2. That's what we are going to find. So that is S2. In BC section, the initial velocity is the velocity at the point B, that is Vmax. In BC section, the initial velocity is the velocity at the point B, that is Vmax. So here the thing should be changed. Look at board. Look at board. B to C displacement S2, initial velocity, the velocity at the point B, Vmax, time taken T2, plus half acceleration A2 time is T2, and we have to get the square. Right? Then S2 equals, we have found Vmax as 12, time taken is given as 10, plus half acceleration. A2 is not an acceleration. B to C it's a deceleration. Therefore, A2 is a minus something. So it is minus 1.2, the time 10, and we have to get the square. So S2 equals 12 into 10 is 120, minus into positive minus halves. 1.2 can be written as 12 over 10. 10 square is 100. Can you understand this, maths dear? I have multiplied this minus sign, positive sign. I got a minus sign. Minus into positive minus. 1.2 is written as 12 over 10. Now I can easily cancel out this 0 and this 0. Then I'll get S2 equals 120 minus 12 divided by 2 is 6 into 10. 12 divided by 2 is 6 into 10. So then S2 equals 120 minus 60. 60 into 10 is 60. That is 60 meters. 120 minus 60 is 60. So we have found S1, S2 found, Vmax found, A2 also found. Please complete everything. Write down everything. And if you have any further doubt, please ask. Right, so we have answers, right? So they ask us to find the maximum velocity as the Roman number 1. So Vmax is 12 meter per second. Then they ask us to find the deceleration. So A2 equals minus 1.2 meter per square seconds. If you want, you can write with the minus sign, or you can say deceleration. If you say deceleration, no need to write the minus sign. At once you can write 1.2. If you use the word deceleration, so no need to write the minus sign, right? So total displacement means summation. They ask us to find total displacement, that is S1 plus S2. S1 is 180, S2 is 60. So therefore, this is 240 meter is the total displacement. So we have completely solved the example. The same story is given. The same story is given in question number 5 in paper 1, but they have not used numbers. They have not used numbers 0.4. They have not used 30 seconds, 10 seconds. They have used only the symbols, right? So we have used the symbols to solve this problem, right? I'll erase everything and please read question number 5, which is given in paper 1. I'll read the question for you. Listen carefully. Theory paper 1, question number 5. An object starts to move at rest, and it travels along a straight road with a constant acceleration of alpha. Then it decelerates with a constant rate beta and comes to rest. The total displacement of the object is s meter. And the object starts to move at rest and it travels along a straight road with a constant acceleration of alpha. Now, initial velocity 0, acceleration not 0.4. They have given a letter, right? They have indicated acceleration as alpha, meter per square seconds. Can you identify it? It's not a number. Alpha may be 1, alpha may be 2, alpha may be 1.2, alpha may be 0.4, anything. So they have said that acceleration from A to B is alpha meter per square seconds. It travels along this road, but they have not given the time taken that the object accelerates. They have not given the time taken. And the other thing, they have not given the displacement from A to B. So at the end of the acceleration time period, as earlier, maximum velocity will be there at the end of the acceleration. A to B velocity increases, B to C velocity decreases. Then B to C, it says deceleration. So A2 is acceleration. B to C has a deceleration, and deceleration is said to be beta. So as it's a deceleration, we have to say A2 equals minus beta. Unit is meter per square seconds. Why did I put a minus sign there? Because it's a deceleration. A2 is an acceleration. B to C, there's a deceleration. Therefore, A2 equals minus beta. And they have not given this time taken. They have not given this time taken. The only available data, the only data given in the question is total displacement is said to be s meter. So please draw this figure for theory paper 1, question number 5. Draw this figure quick. If you have completely drawn the figure, please send me a message saying done, because I can't see your books because this is an online class. Right. Look at board. Look at board. The only given data is S. And if you check the answers, you will see they ask us to find the maximum velocity. You will see maximum velocity equals something inside the square root. Then they ask you to find the total time taken. Again, there will be a square root. So there will be square roots in the answers. They ask you to prove two expressions for one for the maximum velocity, the other one for the total time taken. So you will see square roots. So if you want to get a square root, if you want to have a square root in your final answer, you have to use the equation with square terms. If you want to have square roots in your final answer, you have to use the equation with the square terms. The only equation with the square term is v square equals u square plus 2as. So therefore, I use this AB section. I use this AB section and I indicate the direction. Then I use the equation v square equals u square plus 2as. If you consider AB section, the velocity at A is the initial velocity, that is 0. In AB section, initial velocity means velocity at A, that is 0. Plus 2, acceleration, A to B acceleration A1, displacement from A to B S1. The velocity at the point B is the maximum velocity obtained by the vehicle. In AB section, the final velocity is the velocity at the point B, that is Vmax. So Vmax equals 0 square is 0 to A1 is given as alpha, S is S1. So Vmax equals 2 alpha S1. So next case, I'll take this 2 alpha term to this side. Vmax equals 2 alpha times S1. I'll take 2 alpha to this side by using cross multiplication. Then we will get Vmax over 2 alpha equals S1. Please mark this as the first equation. Start. You start, write everything, and if you have any doubt, please ask. Don't keep your doubts, difficulties in your mind. You must talk to me. You must ask. right? Then let's use the same equation from B to C. Look at board. Let's use the same equation from B to C. B to C section to this direction, I'll apply the equation V square equals U square plus 2AS. BC section, the final velocity is the velocity at the point C, that is 0. Final velocity is the velocity at the point C, it is 0. In BC section, initial velocity means the velocity at the point B, that is Vmax. Initial velocity means velocity at the point B, that is Vmax. Equals square plus 2 acceleration. B to C acceleration is A2, B to C displacement is S2. Right? So 0 square is 0, Vmax square plus 2. A2 is acceleration, but B to C it has a deceleration of beta, therefore we should write a minus sign for A2. So it is minus beta into S2. Minus into positive minus, then you get 2 beta S2. This 0 will not change, this Vmax will not change. Minus 2 beta S2 comes this side as positive 2 beta S2 equals Vmax square. So I'll take this 2 beta to this side by using cross multiplication. Minus 2 beta comes to this side as positive 2 beta S2, and I'll take 2 beta to the other side by using cross multiplication. So then we'll get V max square divided by 2 beta. That is our second equation. Now we have two equations, one for S1, the other one for S2. Start quick. Start, write them all, and if you have any doubt, please ask. Look at board here. In the previous A to B equation, look at board. In previous A to B equation, V square equals U square plus 2A. So V square. So this should be Vmax square. V square, and this should also be square. And here also it should be square. So this should also be square. So please put Vmax square for all the Vmax terms in the equation number 1. So here it's okay. All the terms, I have kept Vmax square as Vmax square. Clear? So that was a mistake. Please correct it. So we have two equations for H1 and H2 with Vmax square. Right? Complete. Right now it's so simple. They have said that total displacement is S. So I'm going to use it to obtain the answer. Right? Look at board. Look at board. So total displacement is given as S meter. So I write it total displacement. They have given it as S. A to C total displacement S. But if you consider the figure, the total displacement is S1 plus S2. So total displacement is S1 plus S2 and it is equal to S. The first equation tells us S1. S1 is given by the first equation. So according to the first equation, S1 is V max square divided by 2 alpha. According to the second equation, this one, according to the second equation, V max S2 is V max square over 2 beta. V max square over 2 beta equals S. Now, write these three steps and look at the first answer given in the question and suggest me a method. Suggest me the next step. What should I do next? You have a chance to suggest me. Think, write, try. Have you found any method? Huh? Have you found any method? It's so easy there. You see, in your answers, if you check your first answer, you will say 2 alpha beta S. If you check your answers, the first answer asks you to find an expression for V max. There you will find 2 alpha beta S. So if you see 2 alpha beta S in your answers, the best thing that you want to do is V max square over 2 alpha should be multiplied by 2 alpha beta. And V max square over 2 beta, multiply this also 2 alpha beta. And here this S, multiply S also by 2 alpha beta S. Multiply this also by 2 alpha beta. So all the three terms in the equation I have multiplied by 2 alpha beta. Now you see this, This 2 and this 2 cancelled out. Alpha to alpha cancelled out. Similarly, 2 and 2 cancelled out. Beta to beta cancelled out. So the remaining terms will be Vmax square into beta plus Vmax square into alpha equals S into 2 into alpha into beta. S into 2 into alpha into beta can be written as 2 alpha beta S. 2 alpha beta S. Now you see this. Look at what stop writing. I have multiplied all the terms by 2 alpha beta S. Then 2 and 2 alpha alpha cancelled out. 2 and 2 beta to beta cancelled out. The remaining terms Vmax square beta, Vmax square alpha. Now you see Vmax square common. Therefore, square of Vmax can be taken out from a bracket. So I'll take it out. Vmax square can be taken out from a bracket. And here I will have 2 alpha beta S. Once Vmax square is taken out, remaining term beta. Once Vmax square taken out, the remaining term is alpha. So I'll take this to this side, then I'll get Vmax square equals 2 alpha beta S divided by, this part comes to here, beta plus alpha. Beta plus alpha. I'll write it here. So let me write this term here so I can erase it. Right, now look at board. Look at board. Now we have the answer. Right, one more step. Vmax square equals 2 alpha beta S divided by beta plus alpha. Beta plus alpha can be written as alpha plus beta. Why? Beta plus alpha can be written as alpha plus beta. Why is that? Very simple. Very simple. 1 plus 3 is 4. 3 plus 1 is also 4. Whether it is alpha plus beta or beta plus alpha, no change. So in the place of beta plus alpha, I have written alpha plus beta, not changed. So the final thing is, if Vmax square is this, then Vmax should be equal to square root 2 alpha beta S over alpha plus beta. So this is the final answer. Complete, write down everything, and if you have any further doubt, I'm here to answer. Write it. Right, so let's going to obtain an expression for the total time taken, right? So they have asked us to obtain an expression for the total time taken. So the total displacement case is over. We are going to find an expression for total time taken. So total time taken means T1 plus T2. In this kind linear motion frictions, the best equation to find time is V equals U plus A. I'll not erase these things, don't worry. I'll not erase, promise. The best way to find the time taken for a motion in linear motion equations is using the V equals U plus AT equation, right? So first I use this AB section. First I use this AB section, A to B to this direction. I apply the equation V equals U plus A. So what am I going to do here? I'm going to apply V equals U plus AP for AB section. When AB section is considered, the final velocity is the velocity at the point B, that is V max. That is V max. The initial velocity is the velocity at the point A, that is 0. Initial velocity is 0. Velocity at A is the initial velocity. Acceleration is alpha, time taken is given as T1. So V max equals alpha times T1. If you take alpha to this side, you will get that V max over alpha. If you take it to this side by cross multiplication, V max over alpha equals T1. I'll take this as my capital A equation. Write it. Just write it. So we have obtained an expression for capital T1. We are going to obtain an expression for the total time taken for the motion. Start. So this is real physics. Units and dimensions are not the real physics, and it's a very simple, easy lesson. Right. I'll apply the same equation from B to C section. B to C section. I'll apply the same equation. V equals U plus AT. The same equation into the same direction. In BC section, the final velocity is the velocity at the point C, that is 0. In BC section, the initial velocity is the velocity at the point B, that is V max. This is V max. Plus acceleration. B to C does not have an acceleration, it's a deceleration. Therefore, you have to write it with the minus sign, minus beta, because B to C, the vehicle decelerates. Time taken is T2. So 0 equals V max minus into positive minus beta times T2. Minus beta T2 comes this side as positive beta T2. Positive beta T2 equals V max. If you take beta to the other side by using cross multiplication, you can subject T2 as V max T2 beta goes to the other side, Vmax divided by beta, that is our capital B equation. Now we have an equation for T1 and we have an equation for T2. So T1 plus T2 is the total time taken. That's what I'm going to write. Just complete them all quick. Okay, let's go to the final section, the total time taken for the motion. So let me write here total time taken. Let's say it is capital T. So we know that the total time taken means T1 plus T2. So total time taken is T1 plus T2 equals capital T. T1 is given by the equation capital A, that is V max over alpha, no square, right? Just V equal U plus 80, there is no square term here. So T1 is V max divided by alpha. T2 is given by the capital B equation, that is V max over beta. V max over beta equals capital T. Now, if you look at the answer, you will see alpha beta. If you look at the answer, you will see alpha into beta in your answers. Or if you don't see such a thing, the easiest method to simplify this kind of equation is, look at both, V max over alpha plus V max over beta equals capital T. The easiest way to simplify this kind of equation is multiply this term by alpha beta. Similarly, multiply this term also by alpha beta. Do the same thing, multiply this also by alpha beta. So we have multiplied all the terms by alpha beta. So that's what we want to do. Complete it here. Complete it. Please write them. I'll write these two terms that side because I want to use them in future. So, no, these are erased, right? So I'll write that V max square. V max square is 2 alpha beta s over alpha plus beta and V max. Because I want to erase the board, I want to clear this area for the simplification. So I write this equation there. So V max equals square root of 2 alpha beta s over alpha plus beta. Write down everything, so I'll erase them here. So these are not simple questions. These are in real examination level. So it takes time. These kind of questions take time. If questions are very simple, if they are not in the examination level, you can discuss about 50 to 60 questions within 1 or 2 hours. So it's a waste of time. So you should do the question, you should try for the questions which are really at the advanced level. This is advanced level, not O level part 2. This is advanced level, not O level part 2. Please remember it. Right. So what can we do next here? What can we do next? We have multiplied all the terms by alpha, beta, alpha, beta, alpha, beta. The point here is this alpha and this alpha cancelled out, beta to beta cancelled out. The remaining terms, V max into beta plus V max, the remaining term here is alpha equals T into alpha beta. So you see that V max common. Therefore, I can take V max out from a bracket. So the remaining terms will be V max taken out, beta is there, V max taken out, alpha is there, equals T into alpha beta. Now, V max beta plus alpha can be written as alpha plus beta, no difference. 1 plus 3 equal 4, 3 plus 1 equal 4. Whether it is beta plus alpha, alpha plus beta, no difference. So that is equal to T into alpha beta. Please write the things up to this here. Please write all the things up to here quick. I think you have written them. I'll take this alpha beta term to this side, then I can subject capital T. If you take alpha beta term to this side, it will be, you can subject capital T. So then capital T equals V max into alpha plus beta. I'll take this alpha plus beta to this side by cross multiplication divided by alpha beta. So there are two methods to obtain the answer. I would like to use this Vmax square term. Therefore, I'll get the square of the equation both sides. So T square equals Vmax into alpha plus beta divided by alpha beta and square of everything. I got the square of the equation both sides. Look at board. Stop writing. Look at board. So then T square equals square of V max square. Square of alpha plus beta square. Square of alpha beta square. Now you see T square equals V max square. Here V max square is, I have written in red color. We have already obtained this equation. So V max square equals 2 alpha beta S divided by alpha plus beta. So this is the expression for V max square, V max square. The remaining terms, alpha plus beta square divided by alpha beta square. Got it? So please write these two steps. We just want to write about at least within 2 steps we can get the answer. Write it quick. Do you want any more time to write this? Or may I continue? Look at board. So I have to write it here. I have to write it here. Look at board carefully. Look at board. Right. T square equals 2 into alpha beta into S divided by alpha plus beta into alpha plus beta square. Alpha plus beta square means if you write 2 square, you will write 2 into 2. If you write 4 square, you will write 4 into 2. Similarly, alpha plus beta square means alpha plus beta into alpha plus beta divided by alpha beta square, same thing. That is alpha beta into alpha beta. Now we can cancel out similar terms. Alpha beta to alpha beta, alpha plus beta to alpha plus beta, alpha beta to alpha beta cancelled out. So the remaining terms will be T square equals 2 into S into alpha plus beta divided by alpha beta, right? So if you divide this, finally you can arrange the equation in this format. T square equals 2 into, I'll write alpha beta plus beta. I'll write this S next into S divided by alpha beta. So T square is this. We want to obtain T, therefore we should get the square root. So then T equals square root of 2 alpha plus beta into S divided by alpha beta. So T is the total time taken. They have asked us to obtain this expression for the total time taken. We did it. So please be happy. Write them all quick. So we have reached to the end of the class, right? So we have completely answered all the questions in theory paper 1. After the class, I'll send you some YouTube videos. There will be about 4 YouTube videos. Please watch them all before you join to the next week class. So I would like to change the date and time of this online class. Please tell me whether you are free on Wednesdays 2:30 to 5:30. So I would like to keep the group 3 into Tuesday. Not to Tuesday, Wednesday 2:30 to 5:30. So if you are not free at that time, send me a message. But it will be much easy for me if you join to Wednesday class from 2:30 to 5:30. Got it? So that's enough for today, right? This is enough for today, right?